It's very easy in this case to take EV cache for granted. Let me tell you why. It can handle 30 million requests per second across the clusters we have globally, which is 2 trillion requests per day. It stores hundreds of billions of objects in tens of thousands of memcached instances. And here's the biggest win here. It consistently scales in a linear way such that requests can be returned within a matter of milliseconds, no matter what the load is. Obviously, you need to have enough nodes, but it scales really well. And we had a scenario several years ago where our subscriber service was leaning on EV cache a little bit too much. And this is another anti-pattern worth talking about. It was called by almost every service. I mean, everybody wants to know about the subscriber and what's their customer ID and how do I go access some other piece of information. It had online and offline calls going to the same cluster, the same EV cache cluster. So batch processes doing recommendations, looking up subscriber information, plus the real-time call path. And in many cases, it was called multiple times, even with the same application within the life cycle of a single request. It was treated as if you could freely call the cache as often as you wanted to, so that at peak, we were seeing load of 800,000 to 1 million requests per second against the service tier. The fallback was a logical one when you were thinking about it from a one-off perspective. I just got a cache miss. Let me go call into the service. The problem was the fallback also, when the entire EV cache layer went down, was still a fallback to the service and the database. And that's the anti-pattern. The service and the database couldn't possibly handle the load that EV cache was shouldering. And so the right approach was to fail fast. So with this excessive load, we saw EV cache go down. It took down the entire subscriber service. And the solutions were several. The first thing is stop hammering away at the same set of systems for batch and real-time. Do request level caching, so you're not repeatedly calling the same service over and over again as if it was free. Make that first hit expensive and the rest of them free throughout the life cycle of the request. And something we haven't done yet, but will very likely do, is embed a secure token within the devices themselves that they pass with their requests. So if the subscriber service is unavailable, you can fall back to that data stored in that encrypted token. It should have enough information to identify the customer and do the fundamental operations for keeping the service up for that customer so they can get some kind of reasonable experience. And then, of course, you want to put this under load using chaos exercises, using tools like Fit. Now let's move on and let's talk about variance. This is variety in your architecture. And the more variance you have, the greater your challenges are going to be because it increases the complexity of the environment you're managing. I'm going to talk about 2 use cases. One is operational drift that happens over time. The other is the introduction that we've had recently over the last few years of new languages and containers within our architecture. Operational drift is something that's unintentional. We don't do this on purpose, but it does happen quite naturally. Drift over time looks something like setting your alert thresholds and keeping those maintained because those will change over time. Your timeouts and your retry settings might change. Maybe you've added a new batch operation that should take longer. Your throughput will likely degrade over time unless you're constantly squeeze testing, because as you add new functionality, that's likely to slow things down. And then you can also get this drift sort of across services. Let's say you found a great practice for keeping services up and running, but only half of your teams have actually embraced that practice. So the first time we go and reach out to teams and say, hey, let's go figure this out. Let's go get your alerts all tuned. Let's do some squeeze testing. Let's get you all tuned up and make sure service is going to be highly reliable and well-performant. And usually we get a pretty enthusiastic response on that first pass. But humans are not very good at doing this very repetitive sort of manual stuff. Most people would rather be doing something else, or they need to do their day job, like go and build product for their product managers, the next A/B test we need to roll out. And so the next time we go, we tend not to get that same level of enthusiasm when we say, hey, sorry, but you're going to need to go do this again. You can really take a lesson again from biology with this concept of the autonomic nervous system. There's lots of functions that your body just takes care of, and you don't have to think about it. You don't have to think about how you digest food. You don't have to think about breathing, or you would die when you fell asleep. And likewise, you want to make sure you set up an environment where you can make as many of these best practices subconscious, or not required for people to really spend a lot of time thinking about. And the way that we've done that at Netflix is by building out a cycle of continuous learning and automation. And typically that learning comes from some kind of incident. We just had an outage. We get people on a call. We hopefully alleviate customer pain. We do an incident review to make sure that we understand what happened, and then immediately do some kind of remediation, hopefully, to make sure, at least tactically, that that works well. But then we do some analysis. Is this a new pattern? Is there a best practice that we can derive from this? Is this a recurring issue where if we could come up with some kind of solution, it would be very high impact? And then, of course, you want to automate that wherever possible. And then, of course, you want to drive adoption to make sure that that gets integrated. This is how knowledge becomes code, and it gets integrated directly into your microservice architecture. Over the years, we've accumulated a set of these best practices. We call it production ready. This is a checklist, and it's a program within Netflix. Virtually every single one of these has some kind of automation behind it and a continuous improvement model where we're trying to make them better. Whether that's having a great alerting strategy, making sure you're using auto-scaling, using Chaos Monkey to test out your stateless service, doing red-black pushes to make sure that you can roll back quickly, and one of the really important ones, staging your deployments so that you don't push out bad code to all regions simultaneously. Of course, all of these are automated. And now I'm going to jump over. I'm going to talk about polyglot and containers. This is something that's come about really just in the last few years. And this is an intentional form of variance. These are people consciously going, I want to introduce new technologies into the microservice architecture. When I first started managing operations engineering about 3 years ago, we came up with this construct of the paved road. The paved road was a set of sort of best-of-breed technologies that worked best for Netflix, with automation and integration sort of baked in, so that our developers could be as agile as possible, that if they got on the paved road, they were going to have a really, really efficient experience. We focused on Java, and what I'm now going to call bare bones EC2, which is a bit of an oxymoron, but basically using EC2 as opposed to containers. While we were building that out, and very proud of ourselves for getting this working well, our internal customers, our engineering customers, were going off-road and building out their own paths. Started innocuously enough with Python, doing operational work, made perfect sense. We had some back office applications written in Ruby. And then things got sort of interesting when our web team said, you know, we're going to abandon the JVM and we're actually going to rewrite the web application in Node.js. That's when things got very interesting. And then as we added in Docker, things become very challenging. Now, the reasons we did this were logical. It made a lot of sense to embrace these technologies. However, things got real when we started talking about putting these technologies into the critical path for our customers. And it actually makes a lot of sense to do so. Let me tell you why. So the API gateway actually had a capability, or has a capability, to integrate Groovy scripts that can act as endpoints for the UI teams. And they can version every single one of those scripts, so that as they make changes, they can deploy a change out into production that has onto devices out in the field, and have that sync up with that endpoint that's running within the API gateway. But this is another example of the monolith. Lots of code running in process with a lot of variety and people with different understandings of how that service works. And we've had situations where endpoints got deleted, or where the script or some script went rogue, generated too many versions of something, and ate up all of the memory available on the API service. So again, a monolithic pattern to be avoided. And so the logical solution is to take those endpoints and push them out of the API service. And in this case, the plan is to move those into Node.js, little Node.js applications running in Docker containers. And then those would, of course, call back into the API service, and now we've got our separation of concerns again. Now we can isolate any breakage or challenges that are introduced by those Node applications. Now, this doesn't come without a cost. In fact, there's a rather large cost that comes with these kinds of changes, and so it's very important to be thoughtful about it. The UI teams that were using the Groovy scripts were used to a very efficient model for how they did their development. They didn't have to spend a lot of time managing the infrastructure. They got to write scripts, check them in, and they were done. And so trying to replicate that with a Node.js and Docker container methodology takes a substantial amount of additional work. The insight and triage capabilities are different. If you're running in a container and you're asking about how much CPU is being consumed or how much memory, you have to treat that differently. You have to have different tooling, and you have to instrument those applications in different ways. We have a base AMI that was pretty generic, that was used across all of our applications. Now that's being fragmented out and more specialized. Node management is huge. There is no architecture out there or no technology out there today that we can use out of the box that allows us to manage these applications the way that we want to in the cloud. And so there's an entirely new tier called Titus being built that allows us to do all the workload management and the equivalent of auto scaling and node replacement and all of that. So Netflix is making a fairly huge investment in that area. And then all the work we did over the years running in the JVM with our platform code, making people efficient by providing a bunch of services. Now we have decisions to make. Do we duplicate them? Do we not provide them and let those teams running in Node have to write their own direct REST calls and manage all of that themselves? So that's being discussed, and there's a certain amount of compromise happening there. Some of the platform functionality is going to be written natively in Node, for example. And then, of course, anytime you introduce a new technology into production, we saw this when we moved to the cloud. We saw this every time we've done a major re-architecture. You're going to break things, and things will break in interesting and new ways that you haven't yet encountered. And so there's a learning curve before you're actually going to become good at this. And so rather than one paved road, we now have a proliferation of paved roads. And this is a real challenge for the teams that are centralized, that are finite, that are trying to provide support to the rest of the engineering organization. So we had a big debate about this a few months ago, and the stance where we landed was the most important thing was to make sure that we really raised awareness of costs